Alright, today we're going to be looking at Chapter 4, Topic 12, and this is Day 1. We'll look at this again tomorrow, and this is or Monday, and this is a little thing called completing the square. It's a very useful method of working with quadratics in order to not only solve quadratics, but also to put them into vertex form. If you remember graphing in vertex form was y is equal to a, x minus h squared plus k, where h comma k was the vertex. This x minus h squared is actually a perfect square. And a perfect square trinomial is a trinomial that factors into the same two factors. So x squared plus 8x plus 16. You can see positive 16, positive 8, that it factors into x plus 4, or x plus 4 squared. Same thing with x squared minus 20x plus 100 factors into x minus 10 squared. X squared minus x plus 1/4 factors into x minus 1/2 squared. And x squared plus 3/2 x plus 9/16 factors into x plus 3/4 squared. And x squared minus 7/5 x plus 49/100 factors into x minus 7/10 squared. Alright, and you're probably looking at this, all these x's are the same, but you're probably asking yourself, well, how do you get this number right here? Where is this number coming from? Well, this number has two properties to it. It's the square root of this, and it's half of this. And that is how it is, that is its relationship with each of the b and c's. Okay, this is half of this, and it's the square root of this. 1/2 is half of -1, negative 1/2 is half of -1, and it's the square root of 1/4. Same thing here. 3/4 is half of 3/2, and it's the square root of 9/16. Negative 7/10 is half of negative 7/5, and it's the square root of 49/100. So this does have relationships with these two. And this is actually going to help us find something important here. It's actually going to help us create perfect square trinomials. Because if we know what the middle term is, well, let's see what it looks like to create a perfect square trinomial. So here are the steps. I will show you the steps, but these are the actual steps. We will come back to this when we actually look at completing the square. But first, let's focus on creating perfect square trinomials. So each of these is missing the last value that makes it a perfect square trinomial. And we want to know what could that last value be to make it a perfect square trinomial, and what would it factor into? Alright, well, the key here is that if you take half of the b term and square it, that gives you your c term. And then it allows you to factor it into a perfect square, x plus b/2 squared. Both the factors would be x plus b/2. So first, let's figure out what the c is. So we'll look at the b, we'll take half of that, which is 4, and then we'll square it. So we know that this needs to be plus 16 in order for this to be a perfect square trinomial. And then we do also know what it factors into, because we just need half of b right here, b/2. So it factors into x plus 4 squared. Let's take a look at this one, x squared minus 16x plus c. Well, the c is going to be half of the b term squared. So half of negative 16 is negative 8. Negative 8 squared is 64, so it's going to be positive 60. Well, this last term will always be positive when you're doing this. Middle term, maybe not. Which means that it factors into a perfect square, x and then half of b minus 8 squared. 8 times 8 is 64. 8 plus negative 8 plus negative 8 is negative 16. For this one, we'll take half of 11, which is 11 over 2, and then we'll square it, which is 121 over 4. So this would be 121 over 4. And then it would factor into x minus 11 over 2 squared. It's just half of the middle. The middle is, the b term is negative 11, so it's negative 11 over 2, half of it. Same thing here. So 9x, so we want half of that, so 9 halves squared. So this is 181 over, sorry, 81. I don't know, whoops. Oh no, alright. 81, sorry, over 4. So the c is 81 over 4. And that's what we'd have to add. That was c would have to be to make this perfect square. And we could factor this into x plus 9 over 2 squared. So this is how you make a perfect square trinomial. And this is all great and everything, but how do you use this to any great degree? What is this going to do for us? Well, it actually allows us to solve quadratic equations. This is where we want to go back to the notes here. First of all, make sure the equation's in standard form. Ax squared plus bx plus c equals 0. If a is not 1, everything gets divided by a. This process only works if a is 1. So if a is not 1, we got to divide everything by a so that a becomes 1. So this by a, this by a, this by a, this by a. Bring c to the other side. So you would subtract c to the other side. Alright. And then leave blanks on both sides for the next step, which is where we're going to create the perfect square trinomial. After we've moved c to the other side, we're going to put blanks on both sides to create the perfect square trinomial. Complete the square by adding b over 2 squared to both sides, factor the perfect square trinomial, and then solve the quadratic by square root method, and solve both equations, plus or minus. Let's see what this actually looks like. Much easier to see an example. So a is 1, not a problem there. Don't need to do any division to make a 1. A is 1, it just says x squared. So first step, let's put this 24 on the other side. So we got x squared minus 10x equals 24. Alright. I want to complete the square on the left side. I want to make a perfect square trinomial, which means I'm going to have to add something to the left side, some c value to make this a perfect square trinomial. However, you can't just add something to the left side without doing it to the right side. So I'm also going to add whatever that value is to the right side. Whatever this value is that makes this a perfect square trinomial. Which, remember, to figure that out, I'm taking half of this middle term and squaring it. So half of negative 10 is negative 5, and negative 5 squared is 25. So I'm adding 25 here to make this a perfect square. I'm also adding 25 here because I've got to do it to both sides. Alright. Now, this is a perfect square. It has the same two factors, x minus 5 and x minus 5. So it's x minus 5 squared. And x minus 5 squared is equal to 49. Alright, I'm going to wrap around up here. Now, so what I've got so far is x minus 5 squared is equal to 49. Whoops. Is equal to 49. Well, now I can use square root method to get rid of this square over here, because the whole side is squared, so I can get rid of the square by taking square root, because the square root will get rid of the square on this side. And I'll be left with, I'm going to do this down here, x minus 5, because the square is gone, and then this is square root of 49, which is plus or minus 7. Alright, I want to solve this for x, so I need to add 5. So what I have here, x equals 5, because of this plus 5, plus or minus 7. I've got two solutions here. One of these solutions is 5 plus 7. One of these solutions is 5 minus 7. So one of my solutions is 12. Another solution is negative 2. And those are my two solutions. And I could write them as a set of solutions if I wanted to, 12 and negative 2. Very useful strategy for doing this. Very useful strategy here for solving a quadratic. No factoring involved whatsoever. This is actually quite a bit faster than factoring x squared minus 10x minus 24. And some problems can't be factored, and this is the method that's used to take care of problems that can't be factored. Let's look at number 2. X squared plus 6x plus 4 equals 0. X squared plus 6x plus 4 equals 0. Alright. First of all, divide out a. Well, a is 1, so we don't need to divide out a. We do need to move the constant to the other side. So we get x squared plus 6x equals negative 4. However, remember, we're going to be adding something on both sides. So leave that little space because we want to create a perfect square on the left side. So to create a perfect square, this number, we find this by taking half of this term and squaring it. So half of 6 is 3. 3 squared is 9. Remember, that c is equal to b over 2 squared. I'm going to add 9 to the other side as well. This is a perfect square. Remember, it's in the form x plus b over 2 squared, half of the middle term, squared, and then squared on the outside. Because both the factors of x squared plus 6x plus 9, they're both the same thing. They're both x plus 3. And on the right side, negative 4 plus 9, I have 5. Alright, at this point, I can get rid of this square here by taking square root. Take square root to the left, take the square root to the right. Since I'm solving, this is plus or minus, and the square cancels. And I'm left with x plus 3 equals plus minus 5. Square root 5, sorry. Square root 5 is simplified. That's not getting simplified any more than it is right now. So we're just going to have to leave it like that. Let's solve for x. So subtract 3. So our solutions, x is equal to negative 3 plus or minus the square root of 5. This would provide me with two solutions. X equals negative 3 plus the square root of 5, and x equals negative 3 minus the square root of 5. This could also be written as a set. Negative 3 plus square root of 5, negative 3 minus square root of 5. This one would not have been factorable. This one would not have been factorable. So it's very useful to have this tool here that allows us to solve number 2, because number 2 can't be factored. It just can't, because we wouldn't get anything that provides solutions like this. They got radicals in them. So completing the square is ideal here. Alright, so homework page 53, 9 through 14, and number 18 for day 1.